All right, hey everybody. So we're doing an NLP overview review deep dive today. This doc is linked. I just put it on your Slack channel, but it is also in your homeroom where it is linked. Resources Google Drive, I think. Let me go and check. So this resources Google Drive has pretty much all of the documents that I've gone through over the program. So all of your project resources, like phase 2 has the statistical test stuff. Project 2 guidelines, all the guidelines are there. I put today's and yesterday's in phase 4 because those are technically phase 4 topics, because phase 5, we're going to go through a bunch of these next week. So next week, we're going to talk through resume tips. The Capstone guidelines is here as well. We're going to go over some interview stuff. We'll talk about some post-grad resources as well. So all of that stuff is in this Google Drive, of which you have the link. Cool. Also here, don't forget that I put the link of how to download your material off of Canvas on your Slack channel. I put that on a couple days ago. You will get an email with these instructions as well, but I do highly recommend that you just get that over and done with, because I've had a few students who forgot to do that and then they don't have access and they lose their Illumina stuff. So to prevent that from happening, I recommend that you do that sooner rather than later. Okay, so back to our NLP overview. These are study group notebooks. They're pretty much the same as yours, but these are from a different cohort, same material. I don't feel like changing the URLs to be the ones from your study group notes, but you all have the repo, so they're actually exactly the same. So just to recap some definitions, what exactly is natural language processing? Natural language processing is not to be confused with any of the modeling things, because NLP is really just the process of turning your data from words into numbers. So it's just natural language processing, nothing to do with modeling. If you're doing NLP with classification, that's usually NLP classification project, not just I'm doing NLP. So NLP, remember, specifically refers to the step of processing your text from word form into numerical form. So going from words to a numerical representation of words. This is important as you're explaining your NLP projects. If if you're referring to just that process, it is the NLP process. What about libraries like TextBlob or Vader? So some of you who are the ones who are doing NLP projects that I think these are relevant for, I've sent these links over. TextBlob and Vader are basically pre-built, or they contain pre-built libraries for detecting things like sentiment and polarity. So I've sent these links to a couple of you, each one. So Vader and TextBlob, these are two different libraries. For each one, I've linked the documentation as well as an example of how you use it. Now, Vader and TextBlob are both already pre-built processes. So technically these are doing NLP, but you won't be doing NLP if you were to use one of these libraries. So as an example, Vader is something that you can just plug in text and they'll give you like a sentiment score. So let me scroll to an example over here. So you can use polarity scores, literally just feed in the sentence and it will tell you how positive, negative it is. I forget what compound means, but yeah, you can get that information. You can also get, what is it? Polarity or subjectivity is also one of the things you can get out of Vader. And what's really nice about Vader is it actually takes into consideration capitalization of words, punctuation as well, emojis too. So you see how here you can actually recognize that this smiling emoji, it is partially neutral, partially positive. This one's positive. This seems to be negative neutral. So yeah, that takes that into account. Slang words. So Vader is pre-built. I forget exactly what it's pre-built off of. I wonder if it says over here. But yeah, it is pre-trained on something, which I forget what it is. Maybe social media. I forget. Oh, mechanical. Okay. What it is, not very important. Just knowing that you can use Vader or TextBlob. TextBlob does something very, very similar to just get these sentiment or polarity scores. Now, this is useful if you just want to generate features for your text data, but don't want to use the actual text. You could use something like this. Or even for EDA, I think using Vader or text blob to create features to do EDA on for some like overall general, overall sentiment, overall subjectivity. That could be really interesting. Okay, so next to talk about text pre-processing for our NLP process. So there are a couple different things that you do within processing, and I think I've mentioned this before, but the one downside of doing NLP within Python in a data science process is there aren't many there isn't a library that does everything nicely linearly. So you do see that sometimes you have to, remove stop words to do your EDA, but then you later remove stop words within your vectorizer. So the steps kind of like backtrack on each other, and you're doing things all sorts of different orders, which is very normal at this point in time, because I think only Spacey for word vectors is one that is very, very linear. It's just a one step, you know exactly what you're doing. But for traditional like scikit-learn and NLTK, you're using these different libraries together. So because they weren't built to be used together, you are like doing a lot of different steps at different points in time. So first, we have tokenization. Is really just the process of going from sentences or articles or corpora into individual words, so individual tokens. Now, one way of tokenizing is by just doing like the dot split between your, in your sentence, you just do a dot split on the spaces and you get your words like that. I think in our course, we talked about things like the regex tokenizer. There are actually many different tokenizers that exist. You can do like a tweet tokenizer that specifically takes out hashtags and mentions, stuff like that. There's also sentence tokenizer that turns every phrase or sentence into its own token or a larger form token. And then also, whenever you have anything larger than unigrams. Unigrams is just when it's a single word. Bigrams are for 2 words, trigrams are for 3 words. If you ever want to use those as features, that also falls under the tokenization pre-processing step. Now, I'm going to talk about count vectorizer first, and these things that I'm going to talk about do apply to TF-IDF too. So within count vectorizer, I think count vectorizer is a really useful tool because one, you can use it in your scikit-learn pipelines such that you don't have to have like a separate entire function of cleaning up your data. So several things that you can do here. Strip your accents, that's normal. Whether you turn everything lowercase, you usually want to do that. Where is one that I want to talk about? Oh, here. So you have different tokenizers here where if you have a specific kind of tokenizer you want to use, you can do that. So one that I actually very recently found out, I know to get rid of noise, we talked about lemmatization or stemming is also one, but nowadays most people use lemmatization. And lemmatization for the most part is out of NLTK, not scikit-learn. So using them together, typically a little harder, but recently I actually found out that you can use the lemmatizer in count vectorizer, where all you have to do is to create this new class object such that you can use NLTK's lemma tokenizer within your vectorizer object. So if you wanted to ever streamline your processes, you can actually do it like this. I would honestly just copy and paste what is here, but really what's happening, you need to, in order for scikit-learn to be able to use or recognize this lemmatizer object, you just have to define it this way, such that it knows how to use it. Very, very similar to, this is a little bit off topic, but very similar to if you wanted to do grid search on a Keras neural network. If I ever had that, grid search Keras, I think, let me see, where is, put that somewhere. But basically, if you wanted to do Keras, which is not scikit-learn, within something that is scikit-learn, like grid search is a scikit-learn thing, you would have to build an object for the model so that scikit-learn can recognize it a specific way. Linked somewhere else. I think I linked it on this notebook. There is a step-by-step showing you how you can wrap a non-scikit-learn object into a kind of object that scikit-learn can recognize. I think I put it over here. Check. Nope, not this one. Where did I put it? This one. There you go. So if you have your network over here, you basically have to wrap it, I think like this. Yeah, and then this way it's able to use your neural network within the estimator. So in order to get things to work with scikit-learn, you sometimes have to change the way that the object is. Just something that's in general good to know. Okay, back over here. Other things with Count Vectorizer, you can also add your stop words. This, I think a lot of you were already using, so that's good. If you're using a pattern for your tokenizer, that's good as well. You can create your n-grams within here. Now, I do highly, highly recommend that once you start using anything larger than unigrams, that you start to control the number of features that you have. Because if you think about it, if you had, let's say already like 2,000 unique words that you're using, once you go to bigrams, it's going to look at every single combination of 2-word occurrences. So to not have that explode your data set, if you're doing anything like n-grams, or if you just already have a lot of words, I did talk about this yesterday, you do want to set something like max features or play around with min and max df. So max features basically only returns the top however many features by frequency. So maybe you will set that you only want to run your model on the top 10,000 or let's say 2,000 words or bigrams. That will control for that automatically, and it does this ordered by term frequency across the corpus. Also, min and max df, this you can use as well. Here you can say, when building vocabulary, ignore terms that have a document frequency strictly lower than the given threshold. So while max features looks at it across the corpus, like the occurrence of words across the entire data set, min and max df looks at it per row of data. So if you had, let's say you're doing tweets and someone has a typo and that specific word, typoed word only appears one time, not going to be counted at all. So you could play around with these to lower your dimensionality or to, you know, just not have so much noise. And very typically, words that don't appear so much might not be very useful anyways. Like if a word only appears like no more than 5 times across your like 5,000 tweets, might not be very useful for classification either. So these are all things that you can play around with for sure. Okay. So looking through all of the parameters of Count Vectorizer can make your process a lot more streamlined. All right, so yeah, you can create your n-grams through the vectorizer. So in cleaning and filtering, it's kind of different depending on what kind of NLP you're doing. I would kind of separate the two kinds of text pre-processing into either bag of words methods or word vectors, or word embeddings, to be more specific, because everything's a word vector. So if you're using bag of words method, remember that bag of words method, let me see if I can actually talk about this here. Okay, I do, so I won't go so in depth at this point. Bag of words methods are basically ones that don't really care about the order of your words. It's really just looking at occurrences of your words. Doesn't usually take context into context. So if you're using bag of words methods, it's very, very important that you get rid of your stop words, get rid of words that appear a lot, but you don't want your model to really consider. Perhaps words that are very confounding, words that are, you know, maybe appear a lot. If you're doing tweets, things like hashtags, maybe the search term that you use to search to scrape your tweets, things like that you would want to remove. You also want to convert everything to lowercase unless you think that the capitalization of words will be an important feature to use. And then also I mentioned stemming and lemmatizing, how you could also incorporate that into your vectorizer. Stemming and lemmatizing is basically a way of noise reduction where it converts a word into its root. And nowadays, most people use lemmatizing, but lemmatizing gives you a larger feature set than stemming typically. All right. So any questions at this point? Okay, so EDA for NLP. So there is basic EDA. For example, word counts, word clouds, those are always useful for presentations. But also when you're doing your EDA, I think it is more important to consider what is the task at hand. So if you're doing classification or regression, the same things, the same principles hold for any EDA, regardless of if it's text data or numerical data. So if it's classification, you want your EDA to be very comparative between the two classes or however many classes you have. So if you're doing word counts or word clouds, maybe you do word counts and clouds per class. I think some of you did that for your last project already. if you want to look even further into this, if you have a class imbalance, it's also good to look at normalized word counts. Because if you have a class imbalance, if you have 90% of your data one class and 10% in the other, the word counts are going to skew. So usually look at the normalized word counts. You actually get a stronger comparative. Yeah, it's just easier to compare apples to apples that way. So one thing that you can do to actually give yourself a little hint for what the future importances are going to be, this is a little bit more, if you want to get very, very in-depth prior to modeling. You can actually look at the normalized word counts for each class and then find the differences. And usually the ones with the larger difference are going to end up being more important features. So as an example, let's say you're looking for the word good. And the normalized word count for good appears 10% for your negative. The word good is 10% of all words in negative data, 50% of all words in positive data, and you're just going to take the difference between both. So if you take 50% minus 10%, that is a 40% percentage delta. And if you're doing multi-class, you can do this for your different classes as well. But it's very likely if you see a big difference in the normalized word count, it ends up being an important feature. That's a typical pattern that you see. For regression, because you're no longer doing categories, you actually do want to look at your word frequencies against your target variable. Because how do you interpret regression results with text? Especially if you're using bag of words methods, it will be just like occurrence of this word or every occurrence of X word. If you're doing count vectorizer, will increase the target variable by coefficient amount. That's a regression example. So you can look at your word frequencies against your target variable. Same for TF-IDF, because instead of the feature being word count, it'll be word inverse document frequency. So for your most important features post-modeling, for example, if you're looking at your random forest regressive feature importances, or if you're looking at linear regression's highest coefficients, it might be helpful to plot word count versus target variable as a scatter plot. So you can see like, all right, per each occurrence of this word, how does your target variable change? What is the relationship between your target variable and the usage of a word? So these points will be good post-modeling EDA for sure. Okay, so in thinking about vectorizing, first, when do you do train test split in relation to vectorizing? I think you all here are pretty, I'm really comfortable with you all's knowledge on when to do train test split. I think through your projects, you're all doing it at the right place. So I'm not super worried about this, but you always do your chain test split before vectorizing to prevent data leakage. But technically, if you were to use count vectorizer, data leakage doesn't become an issue, right? Because count vectorizer only does the word counts. It doesn't have anything to do with the distribution of your entire data set. But TF-IDF, the values will change if you do it before or after a train test split. Now, one very, very tiny detail is, let's say you had a word that only appeared in your test set, but not in your train set, and you use count vectorizer. That word will, if you were to do it before or after train test split, that word's value will change. So if a word doesn't appear in your train set, but is in your test set, it actually will not even be accounted for in your test set, if that makes sense. So that's where data leakage can come in with a count vectorizer. Cool. All right, so bag of words methods, which is count vectorizer or TF-IDF. Again, for bag of words methods, you only care about the use of specific words, not the order of words being used. Neither do you really care about context. If you're doing some Googling and looking up for different methods, you might come across TF-IDF transformer. So actually, let me pull that up super quick. TF-IDF transformer, which is different from TF-IDF vectorizer. And I'll show you all of that. And I think there's a line somewhere that it says TF-IDF transformer. Okay, I can't find this, but basically TF-IDF transformer is different from TF-IDF vectorizer. The difference being, oh, here, it's equivalent to count vectorizer followed by TF-IDF transformer. So if you ever wanted to try both count vectorizer or TF-IDF, maybe instead of using completely different pipelines, and if you want to make sure that you're using the same words across both, you could technically do count vectorizer followed by TF-IDF transformer followed by your model as your pipeline. But it's equivalent. It's the same thing. It depends on how you want to set it up, how you want to make it look. So just in case you come across this is good to know. And then for word embeddings. Now, word embeddings, it was kind of like an additional topic, not something that you have to incorporate in your project, but I do think for a capstone, especially if your business problem takes context, or if context is very important to your business problem, word embeddings are basically pre-trained numerical representations of text. You have word embeddings, which come from the GenSim library. They're all outlined in the notebook that I shared with you all last phase. And then you have document embeddings, which is Spacey. I do recommend using Spacey unless you're looking at specific things like similarity within a text of words, for example. So I do highly recommend using Spacey because their process is a lot more straightforward, a lot more streamlined. For document embeddings specifically, the idea of cleaning is completely different from when you're dealing with bag of words. Because you're taking context into account, perhaps the usage of capitalization, punctuation, emojis, that can all be taken into account with document embeddings. So typically you don't want to do too much cleaning to preserve as much of the meaning as possible. And you'll see that if you were to take, like, let's say a paragraph and get that document embedding, take the paragraph with lowercase, take that document embedding, the embeddings are going to be different. So because of that, typically if you're doing Spacey, you don't need to clean your data that much. And it's for a good reason too. Okay, questions at this point? Okay, so clustering for NLP, not too much here because I talked about this yesterday. I'll talk about LDA as well. So there's hard clustering and soft clustering. Yesterday we talked about hard clustering. You can use either k-means or HAC, and you can actually give it any vectorized form of your text. You can either give it like a bag of words vectorized data of text, or you can give it your word vectors, and it can help you basically group your data. Really good way of figuring out what the main, or it's a good mathematical or let me rephrase. It's a good way to see mathematically how your data is distributed. But more likely what you will be doing if you want to do any form of clustering is using LDA. And LDA is soft clustering method. That means that each data point of your text can be related to multiple topics. And that's usually very helpful. You can actually get a probability array for every data point. And I linked over here if you want to see an example of using LDA and setting it all up. So here, I think I've sent this all to, I think this is the same one that was linked in the notebook from last phase anyways. But yeah, you end up with something like this that you can actually interact with. You can see that in this case, topics 2 and 3 are very semantically similar. 1 and 4 are kind of separate from that. And then from there, you can look at what the main words that are being used are, and then define your topics like that. So very, very useful EDA tool. Very good for learning about what people or what your data is talking about. All right. And for NLP modeling, you can use any modeling techniques that you like for NLP, as you all know already. Last project, you all did classification, but you can also do regression, and you can use any sort of modeling that, takes in numerical data as long as you first vectorize your text. You can have NLP recommendation engines. You can have semantic similarity recommendations. For example, taking nearest neighbors between text. That's actually very commonly done as well. If you're interested in search optimization, NLP is also very, very relevant to that. But search optimization is outside of our scope of work. Since this link is here, I sent this to a couple of you. Within scikit-learn, there are a lot of machine learning models, not just the ones that we've talked about. So here you have all of these linear models. You have more linear models. You have different support vector machines. Stochastic, that's not relevant to us right now. Different nearest neighbors, all of these things. If you're doing classification, you can see that if I just look up classifier, you can see that there are quite a few. You can even use like Ridge or Lasso for classification. You have SVM for classification and regression as well. I usually recommend that if you're just looking for models to run, you do like a Command F like what I just did here and pick your models there. So if you look at regression, you can see that sure, we have neural network regression, which we know of, but also we have things like, what have we not talked about yet? SVM regression, nearest neighbors regression, decision tree regressor, so on and so forth. Not exactly NLP, but also worth noting. But yeah, I think those are the most important things to think about with NLP. There are just a lot of things to try for NLP, which is what makes it fun, but also difficult to streamline a project in a month, or actually less than a month. So yeah, I think I can give a lot more project-specific advice at our one-on-ones. But cool, that's kind of all I had that I wanted to go through for NLP, kind of like a quick refresher over all the different things that you can incorporate into your projects. And yeah, any questions regarding anything so far? All right, I'm just going to stop the recording here.